It's Sorkin. Welcome to my channel. Today we are going to solve LeetCode 55 jump game problem. So the problem statement is that we have an integer array of nums and we are initially positioned at the first index. So from that index, from the first index, and every element in the array represents a maximum jump from that position. Okay, so we need to return false if we can reach the end of the array last index, or we should return false if we cannot. So for example, in first example, the first element is equals to 2, so we can jump from here to here. So from the second element, since it equals to 3, we can jump to the end of the array. So in this case, we can return true. So in the second example, from the first, the value of the first index is equals to 3. So we can jump to the fourth position here, and the same we can from here we can also jump to the fourth position, and from the third index we can also jump to the fourth position. But the problem is that the value of the fourth index is 0, so which means that we cannot reach the last element, and since we cannot reach the last element, we return false in this case. Okay, so that's the problem. So let's see how we are going to solve it. Okay, let's take example. Let's say we have 2, we have 3, we have 1, we have 0, and we have 3. Okay, so let's take this example and work on it and see that whether we can go from this index to this index using the values of our array. So the approach that we are going to use here is a greedy approach. So the greedy algorithm is, by definition, the local decisions that we are making can lead us to the global solution. So what I mean by that is, for example, in this case, let's maintain one value max, and let's define one variable max, and let's set the value to that max once we go over our array. For example, in this case, let's say that we are starting, this is our first iteration. In the first iteration, so we have only 2, so we are setting the value of max to 2. In the second iteration, we are going to our next index, which is 3. So here, the value of max is not 2, actually, it's 1, because we decremented that, we moved 1 position. So, and now we are making a local decision. Which of these values can take us further, 1 or 3? So obviously 3, because it's more than 1, so we are replacing this value with 3. Okay, so this is our, now we are moving to the next index. Next index is 3, second index, the value of that is 1. So again, we are comparing, so can this value take us further, or the already existing max value will take us further? Of course, this value, because 3 is more than 1, so we are keeping this value, and we are going to the next index, 4. The value is 0, so by the way, we are decrementing that here. So now we become 2, then we are going to the next index, it becomes 1. Okay, now we are comparing 1 with 0, so which one we are taking? So here it was 2, here we took 2, 3, so here we compare 2 with the 1, we are taking 2, here we are comparing 1 with the 0, so which one? We are 1, because 1 more than 0, so we are setting the value of max to 1, and at the end we are reaching the, once we get to the last index, the value of max equals to 0 in our case, but we reach the end, so we are returning true. So that's the solution using the greedy algorithm. So let's put this solution to code. Okay, first thing first, what we are going to do, we are going to define max value, which is equals to 0. Then we are going to go over our array, int I equals to 0, and then I is, while I is less than nums length minus 1, we need to arrive to the last element, but we don't need to consider the value of the last element. That's why we are taking nums length minus 1, and we are just incrementing our I. So the next thing that we are going to do, we are going to update our max, which is for which we are going to use max method, which will take either. So here we are saying, okay, is our current value of our array will take us farther, or the max value will take us farther. So we are making the local decision that will take us to the global solution. So we are taking max, or we are taking nums I. Okay, so which one is the whichever is higher, we are taking that value. So here we say that if at any point max is less than or equals to 0, so it means that we cannot move from that position. So we are stuck there, and we need to return false. Okay. If not, then okay, let's also for each step decrement our max. And if not, if we exit this loop, it means that that's it. We exit this loop. It means that we have solution. We reach the end of our array, so we can return true here. Okay, that's it. Let's check our code. Okay, it works as expected. So let's go over it one more time. So first we are defining our max value, then we are going over our array. So and for each index, we are taking off its value and comparing with our max. Basically what we are saying here is, hey, is this value, if the max or the current value of the index will take us farther. Whichever take us farther, we are updating our max, and if that value equals to 0 or less than that, then we are returning false. Or since we are moving one step at the time, we are decrementing our max value for each step. And once we exit this loop, which means that we reach the end of our array, and we can return true. So that's it. That's it for today. I hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.